So let's talk about when life arose on Earth. So let's take a look at this timeline. So this is a timeline that goes back 4.5 billion years all the way to the present, and then we have sort of an expanded area here that we can look at it at down here. Okay, we're not going to go through all of this in detail because we're going to spend a lot of time actually looking at a lot of this in future parts of this lecture. But let's look at this very beginning because we haven't really talked about how the Earth formed. And in this class, we don't really get into that. That really is a different class actually, where we just talk a lot about the planets themselves, and the geology of the planets and how they formed, and etc. But we don't really do that in this class. I'm just going to give you a quick overview here. So 4.5 billion years ago, the Earth formed. There was a giant impact that actually formed the moon. So imagine something very, very big hit the Earth, it broke off a piece, and formed the moon. So that... Okay, so, and then there was a period of time in which there were so many things hitting the Earth, right? So many meteorites hitting the Earth. It was called heavy bombardment. So this was because the early solar system had a lot of little planetesimals in it. So things were whizzing around, and lots of them were crashing into the Earth. And this made it very difficult for anything to form as far as life goes. And then if we look farther forward, we can see that, oops, sorry about that. We went to the next slide. We didn't mean to. Okay. So if we look a little farther forward, we see here that we have some oldest microfossils. So these are tiny fossils of microscopic life. So we have some evidence of life starting back here, something like 3.5 billion years ago. And then, of course, things moved on from there. And at the time, we really didn't have any oxygen in our atmosphere. That didn't happen. Our evidence for any oxygen at all really happened quite far in the Earth's history, far forward from the beginning. So just keep that in mind as we go forward. Okay. Now, again, life probably arose about 3.85 billion years ago, shortly after all that heavy bombardment ended. And this evidence comes from fossils and carbon isotopes, as we saw, because life actually processes carbon in a different way than non-life. And so we can look at the isotopes of carbon that exist and see evidence for life. Okay. Now there's fossils that we see, of course, in sedimentary rock. You all know about fossils. There's the most famous ones are about fossils of the dinosaurs, but there's many fossils, and it's a lot of fun to go hunt for them yourself. If you've ever been to upstate New York, it's got some of the best fossil hunting ever because they're shale rock, which used to be muddy floor of an ocean. And shale, if you've ever been around shale, it's very, very easy to sort of peel off and expose fossils. It's a lot of fun. So I encourage you to find out in your local area if there's any fossil hunting that you could do. Again, a great thing to do. Anyway, but look at something like the Grand Canyon. That's a record. It really contains a record of 2 billion years of our history in that sort of sedimentary rock. Okay. So again, the oldest fossils show that bacterial organisms were present over 3.5 billion years ago. So life really started pretty quickly after the Earth was formed, and quickly meaning a billion years. And carbon isotope evidence that we mentioned dates the origin of life to a little earlier than that, 3.85 billion years ago. So that's earlier in the Earth's history. So let's talk a little bit more about this idea of a habitable zone that we talked about when we were talking about exoplanets. So this idea of a habitable zone is the area in the orbital area that a planet can be and have liquid water. So if a planet is too close to a star, water just boils away. If it's too far away, water freezes. And you need liquid water. At least on Earth, you needed liquid water to create life. So we call this the habitable zone. Again, we don't really know that that's the only way that you could have life. And you heard a little bit about that in the previous part of the lecture where they were talking about seas of methane, etc. Maybe there's some way that life could use that instead of water. Okay, so the presence of an atmosphere kind of extends that habitable zone. So if you have an atmosphere, gives you a little bit more leeway because you're trapping energy from your star, and allowing, giving yourself a little bit more wiggle room in having liquid water, being hot enough for liquid water. And in our solar system, the habitable zone ranges from about 0.99, so roughly 1 AU, to 1.6 AU, so a little bit past the orbit of Mars. Okay, now the habitable zone of a star really depends on how bright the star is, right? If you have a really bright star, so let's say you have we don't really know about star types yet, but this is a very hot and bright star, the type O star here. If it's very bright, then your habitable zone is going to be farther away. If you have a dim star, cool, dim star, your habitable zone will be farther in. Makes sense. Now, different types of stars have different lifespans. So it completely depends on how bright the star is and how hot. So if you have at least on the main sequence, we haven't really learned about that yet. Just take my word for it. If you have a really hot, bright star, they live or they're very massive stars, they live very short lives. And if that's the case, then you really don't have enough time for life to develop. At least we don't think you might, because given how long it took for life to develop on Earth, you need some time. And these types of stars that live fast and die young just wouldn't work out. At least we think so. Okay. But we know, we think that life may take a long time to develop, right? So that's a different thing than this, which is, we have found life in very extreme conditions, like mentioned in that first video. And we think that, and that really suggests that this idea of the habitable zone really is not as a hard and fast rule, maybe, that we might think it is. Because life has been found in all kinds of things like geothermal vents in the oceans, and in places that are very salty, etc. And sources of energy other than the sun can provide the energy for life. So, for instance, a geothermal vent, it's very hot, and that can provide the energy for life instead of the sun. Okay. All right, so here's a question. Habitable zones require the presence of water of any type? No. Liquid water, yes, that's the whole definition of a habitable zone, even though maybe there are other ways for life to exist. All right, two things that life needs in a habitable zone are liquid water and a source of energy. That is true. You got to have the energy, or you really can't do anything, okay? All right, so that's true. Life can only exist if it uses solar energy of a star. Well, no, we just said that, right? A geothermal vent is providing heat and energy for these animals to use instead of the sun. Okay, so that's false. And now here is your class question. Pause your video now.